This is the biomagnification simulation. So you're looking at how mercury kind of travels up the food chain and why mercury stays in a food chain, because it is fat soluble. So that means that it dissolves in fat, it doesn't dissolve in water. So a fish or a human that's eating something is going to store the mercury in its own fat tissues. So that means that that mercury stays within that organism during its lifetime. And then when you eat another organism, you're going to be ingesting the mercury that's in its fat as well. So we're going to use a traditional silver paperclip to represent mercury. So that's our toxin. And then we have different colored paperclips for each organism, so each level of the food chain. So green is going to be the producer, so the bottom of our trophic pyramid, bottom of our food chain, which is our producer, and that's going to be algae, because we're looking at a ocean aquatic food chain. And then the humans are going to be the apex predator. Then we're going to have a gray paperclip as a primary consumer, zooplankton, pink or red for secondary consumer, which is going to be sardine. The tertiary consumer is going to be purple, that's going to be a tuna fish. And then the human as the apex predator is blue. So we're going to roll a dice each time, and that's going to have our probability for our first green paperclip. So for our producer level, when we roll the dice, that's going to determine how much mercury is in each algae. So I rolled a 4, so that means I'm going to take 4 silver paperclips representing mercury, and I'm going to attach them by linking them together onto this green algae paperclip. So that means this algae is always carrying 4 units of mercury. So next I'm going to roll to determine how many algae the zooplankton is going to eat. So I roll a 4 again. So that means my primary consumer, my zooplankton, is going to eat 4 algae. So I'm going to have to make 3 more of these algae. Each of them is going to have 4 units of mercury attached to them. So that means that because the zooplankton, the primary consumer, is eating 4 algae in its lifetime, it's consuming 4 times 4, or 16 units of mercury. So this zooplankton is going to eat this first algae, then it's going to absorb 4 units of mercury. It's going to eat this second algae. Now it has 8 units of mercury. It's going to eat a third algae, again with 4 units of mercury. And then a fourth. So each time it's eating some algae, it's adding 4 units of mercury to its body. And so we're starting to create our food chain. So we have our producers, which are our algae, primary consumer zooplankton. The algae each has 4 units of mercury, because our zooplankton ate 4 algae, and each algae had 4 units of mercury. Our zooplankton now has 4 times 4, or 16 units of mercury. So that's something that you're going to be keeping track of in this observation. So you need a data table. So next I'm going to roll the dice for the sardine. Okay, to be honest, 6, but I'm going to make it a 2. That's going to be easier. So the sardine is going to eat 2 zooplankton because I rolled a 2. Each sardine, when it's eating the zooplankton, is going to be eating the zooplankton plus it's consuming the algae and the mercury. So we're tracking the mercury going up the food chain. So I'm going to create 2 strands that look exactly the same. So I'm going to need 4 algae because we're assuming that this zooplankton also ate 4 algae. Each of those algae is going to have 4 units of mercury attached to it. So I'm going to start attaching those to this zooplankton. So that means that each zooplankton is eating 4 algae. Each algae has 4 units of mercury. So each zooplankton consumes 16 units of mercury. And then our sardine, which is our red, is eating 2 zooplankton. So it's going to be consuming 2 zooplankton. And then each zooplankton had eaten 4 algae. I need to finish my mercury here. So each zooplankton had eaten 4 algae, and each algae had 4 units of mercury. So you can see now my sardine at my secondary consumer level is going to be ingesting all of this mercury at the bottom here. So it's ingesting 4 times 4 twice. Because I had 4 units of mercury on each algae. So each algae had 4 units of mercury that it had ingested. Then the zooplankton ate 4 algae. So the zooplankton ate 4 times 4 units of mercury. So each zooplankton had 16 units of mercury. Now the sardine has eaten 2 zooplankton, each which had ingested 16 units of mercury. So this is 16 plus 16, or 32 units of mercury that this sardine is then eating. And we're starting to create, you can kind of spread it out here and see your trophic pyramid a little bit. So this is your producer, primary consumer, secondary consumer. And we're going to keep going. Make it easy. I'm going to pretend that I rolled a 2 again. So if I roll a 2 again, that means this tuna, which is going to be purple, is going to eat 2 sardines. Each sardine has eaten 2 zooplankton. Each zooplankton has eaten 4 algae. Each algae has 4 units of mercury. So I have to copy this again because my tuna is eating 2 sardines. And then each of my sardines is eating 2 zooplankton. I'll start linking them. So this is my tuna. It's eaten 2 sardines. Each sardine is eating 2 zooplankton. Each zooplankton is eating 4 algae. These. So these are the 4 algae that this zooplankton ate. And then these are going to be the 4 algae that this zooplankton ate. I'm going to attach those. And then each of these algae had consumed 4 units of mercury. So I'm going to need to add more of my silver paper clips at the bottom. I'm going to add 4 units of mercury for each algae here. So now, as I'm moving up the food chain, each thing, because it's eating more of the trophic level below it, is also ingesting more and more mercury. So each time you eat something, you're ingesting all the toxins it has eaten also. That's going to be why they recommend that you avoid eating fish more than maybe 2 or 3 times a week. Because if you're eating a fish like a tuna, it has consumed all of this mercury from the trophic levels below it. Then I'll keep adding my mercury here, but just in the interest of time, I would roll again to figure out how many tuna the human eats. I'm just going to say it eats 1. So this is my human at the top. So this is why if you only eat tuna once a week, you're only ingesting this much mercury. If you're eating tuna more than once a week, or things like swordfish have a lot of mercury because they're a top predator in the ocean, then you're consuming all the mercury from the trophic levels below. And then because mercury is a fat soluble heavy metal, it's going to build up in your body because it dissolves into your fat stores and it stays with you until you die, or if you're another organism, until you're eaten by something else. So again, in terms of calculations of amount of mercury, the human at the top of this paperclip chain has consumed 1 tuna. That tuna had consumed 2 sardines. Each sardine had eaten 2 zooplankton. Each zooplankton had eaten 4 algae, and each algae carries with it 4 units of mercury. So that means the human at the top is consuming all this mercury. So the top of the pyramid here, the human's consuming 4 times 4 times 4 times 4. So each group here had 4 times 4, or 16 units of mercury. And then there were 4 zooplankton, so 4 times the 16. Then 2 times 4 times 16. And easy, and I just added 1 each time. So that's what you're going to use to fill in your data For the observations, you need to create a data table to track the amount of mercury in each trophic level, so each trophic level as in producer through apex predator. Then you're going to answer these questions here. So you're going to look a little bit at DDT as well, because that was a similar thing that had biomagnification, because DDT was a pesticide to control mosquitoes, but it is also pervasive. It stays in an organism throughout their life, and it can affect that organism's health.